Force. Force is given as what? Mass times acceleration. Mass times acceleration. So our mass is given as kilogram times our acceleration is given as what? As what? Meter per second square. So if we want to write the derived quantity of what? Of our force, it can be written as what? Kilogram meter per second square. This is how we can bring out or generate the SI units, the derived units of our derived quantities. But some of our derived quantities, they still have what we refer to as their SI unit. The derived unit of force is kilogram meter per second square. But our SI unit for force, SI unit of force is called what? Newton. Capital letter N. This is the SI unit for force. So you can see that some of our derived quantities, they have their own SI units in respect to the scientist. This is Sir Isaac Newton. Let's look at another power. Power. Power is another derived quantity. And what is power? Power is what? Is work. Power is work all over time. Work all over time. Power can also be given as what? Energy all over time. You remember in our introduction to physics, we said work can also be equal to what? Energy. So power can be explained, or power is work over what? Time. But what is work now? Let's break it down. Work is given as what? Force times what? Distance. And this is all over what? Time. Force times distance all over time. That is what power is. And we know already what force is. What do we have as our force just now? The unit for our force is kilogram meter per what? Second square. So now let's look at that and see how we can bring out. Our force is given as what? Kilogram times meter all over second square. Now this is times. What do we have? Our distance is length. And length is also what? Meter. Then all over, what do we have? We have what? Time. We have time. So our force, our power here, power can now be written as what? The unit is kilogram. Meter times meter gives us what? Meter square. All over what? Say what? Cube. Seconds cube. Can we take that again? Now let's look at this. So our force now, we know our force to be given as this. Our distance is given as what? Meter. And our time is given as what? Seconds. So we now have how many seconds here? Second square times second, which is our time, give us what? Seconds cube. Meter times meter give us meter square. So that becomes our derived unit for power. But power has its own SI unit. power has its own SI unit. The SI units of power is watts, with a symbol of capital W. So watt is the SI unit of power. Just as our work also, let's look at work. We've already treated work. Work. We can see that our work is equal to what? Force times distance. Force times distance. Force times distance. And our force is given as what? Kilogram meter per second squared. Then times distance, which is our length, meters. So what do we have? Kilogram meter squared per second squared. This is our what? Work. But work also have its own SI unit. SI unit of work. SI unit is what? Referred to as the joule. Capital J as the symbol for the SI unit of work. SI unit of work and energy is joule. Next, we are going to look at dimension. Dimension. Writing the dimension of our quantities. What do we mean by the dimension of a quantity? Is when we are expressing a physical quantity in the initial of its fundamental. Or it can also be expressing a physical quantity in the fundamental units. We refer to it as what? The dimension. Now let's look at this as an example of what dimension is. If, for example, we are giving question like this. 1. Say, write the dimension. Write the dimension of the following. Write the dimension of the following. A. Want to write the dimension of speed. B. Want to write the dimension of acceleration. C. Want to write the dimension of force. Now let me use these three to explain what dimension is all about. Now if you want to write the dimension of speed, let's look at solution. Speed. What is speed? We say speed is what? Length. Length over time. Length over time. So we are going to express this now in the initials. The initial means you are taking the first letter there. This is L, all over what? T, all in capital letters. But we don't leave our dimensions in fractions like this. We express it now as in index form. So our dimension for speed can now be written as what? L T raised to power minus 1. We have represented it in index form. This is what we refer to as what? The dimension of what? Speed. If you go back to the unit, what is the derived unit of speed? Is what? Meter per second. So it is actually, we have expressed the unit, but now in the what? In the initial, using the first letter of their what? Derived quantities. L T raised to the power of minus 1. Now, we are going to look at Writing the dimension of acceleration. Acceleration. You can easily write the dimensions of these derived quantities going back to their what? Their derived units. What is the unit of what? Acceleration. Meter per second square. Meter per second square. Is that not? Now, what is meter? Meter is for what? Length. And what is our second? Second is for time. So it means the dimension cannot be written as what? L t raised to power minus what? 2. So we have written the dimension of what? Acceleration. Now let's look at the next here. Dimension for force. Force is equal to what? Mass times what? Acceleration. Mass times acceleration. And what is the unit for mass? Mass means what? N. So we can take capital letter N times our acceleration was given to us to be what? L all over t squared. So it means the dimension for our force can be written as what? M L t raised to power minus what? 2. Force is mass times acceleration. So we have written the dimension for our force. This is actually what dimension is all about. We are going to take some practical questions which I will put down and you can solve it. Solve it and inbox me the answer. Where you have problems, I will solve them. So now, we are going to look at these questions which I'm giving to all you viewers to solve and inbox the answer or in the comment section. If you cannot, then maybe probably in our subsequent edition we will answer it. Question number 1. Find the values of x, y, and z respectively in the expression m raised to power x, l raised to power y, and t raised to power z for the universal gravitational constant G. And the second question is write the derived units of pressure. Write the derived unit of pressure. Thank you for watching.